What's going on, everybody? So today we are going to talk about solving quadratics by the square root method. So in another video, I talked about solving quadratics with the zero product property, but now we're going to learn a different way to solve quadratics. So we want to use this method when we're dealing with quadratics that look like this. Usually it's just with one number. Let me zoom in a little bit more. It's with one number and we have an x squared, or x squared minus a number equal to another number. It could be 0, could be anything else. Or sometimes they look a little bit more complicated like this. So this is a little bit more simple than the zero product property in my opinion, but I know that different people have different experiences with this. So we're just going to jump right into it. What I want to start off with is inverses. So we have addition and subtraction. For example, we have multiplication and we have division. Those are both inverses of each other, meaning that they are the opposite operations. So if you think of what's the opposite of plus, well, most people would say minus, and most people would be correct. If you ask someone what's the opposite of multiplication, they would probably say division. And so that's what inverses are. In the case of square roots, the inverse of a squared, meaning when you take a number to the power of 2, the inverse of that would be the square root. You can think of it like each of these inverses cancel each other out. So these two inverses would cancel each other out as well. And we're going to use that to solve our problems here. So let me jump into the first example right here. X squared equals 16. Let me zoom in a little bit more as well, and hopefully get that focused. So x squared equals 16. Like I said, when we are looking at any equation and we have a variable that we're trying to solve for, we want to get this variable by itself. We want to get x by itself. So in this case, to do that, I'm noticing that this x is being squared. It's being raised to the power of 2, so I have to do the inverse of that, which is the square root, just like I said. And anytime we do something to one side of this equal sign, we got to do it to the other side as well. So when we do this, what happens is that square and that square root, they're going to cancel each other out. And all we have left is that x right there. So I'm going to rewrite that. And then on the other side of this equal sign, I have the square root of 16. So now all we have to do is figure out what the square root of 16 is. You can use a calculator, sure, but you can also do this in your head, because the square root of a number, that answer is going to be whatever number multiplies itself to get this. So what number, in the case of the square root of 16, what number is going to multiply by itself to equal 16 is going to be 4, because 4 times 4 is 16. So the answer would be 4. But if you think about it further, we know that a positive 4 times a positive 4 is obviously going to get you a positive 16. And there is another way to end up with a positive answer. That could be a negative times a negative. Anytime you have a negative times a negative number, you're going to end up with a positive product. So there are two ways using the same number with the same sign to get a positive outcome. So not only is our answer going to be 4, it's also going to be negative 4. We could write our answer separately like this, or we could say x is equal to positive or negative 4. We use the plus or minus symbol. It looks like a plus sign with an underscore, or a plus sign with the minus sign under that plus sign. However you want to see it, we call this plus or minus. So that's pretty much it. Moving on to example 2, you'll notice that it's the same kind of layout, a little bit different. We have x squared and we have a number, but this time we got a minus number on this side instead of it being over here. But we can very easily move it over to the other side by using inverse operations. So just like we know that the inverse of square is square root, also, like we mentioned earlier, the opposite of subtraction is addition. So if I want to move this number to the other side of this equal sign, I'm going to add that number to both sides. So I'm adding 25 to both sides. On this side it cancels, and on this side we have 0 plus 25. I'll just do that math in my head. It's 25. So now x squared equals 25 looks exactly like x squared equals 16. So I'm going to use the same exact method. I'm going to take the square root of both sides so that this square cancels with this square root. X equals the square root of 25. So the square root of 25 is whatever number multiplies itself to get 25. So in this case, I know it's 5. And I'll use that plus or minus symbol because, like I said, I know that negative 5 times negative 5 will also be positive 25, which is what we have here. So there's our answer there. If you need to copy this down, if you're one of my students, go ahead and pause it, do that now. I'm going to move on to example 3 very quickly. So we have x minus 2 squared equals 9. Notice that the x minus 2 is in parentheses like this, so we can still consider it one number. In that case, I can take the square root of this entire thing, and then I'll take the square root of 9 on this side. And all that happens is the same thing. The square cancels and the square root cancels. But instead of just one x, this time we have two numbers inside x minus 2 in this case. So x minus 2 is equal to the square root of 9. I'll add 2 to both sides. Cancel this out. X equals, I don't want to add the 2 to the 9 in there. I don't want to end up with the square root of 11 because that's mathematically not possible. This is not the way that we would add an irrational number with a rational number. So what I'm going to do is just separate them. I'll write the 2 first, and then I'll say that's plus the square root of 9. And now we can take the square root of 9. You could have done it here before adding the 2. And that's how I showed most other people how to do it. But I just wanted to show that we can do it the other way as well. It's just a little bit more confusing maybe. So I will rewrite this with 2 plus, now the square root of 9 would be plus or minus 3. So I'll write plus 3 and make sure that I change that to a plus or minus sign. So what we have here now is two different possibilities, 2 plus 3 or 2 minus 3. And that's because this 3 could be either positive or negative. So I'm going to consider both options. One option when 3 is positive, and in this case I'll have x equals 2 plus 3. And then the other option where 3 is negative, and I'll have x equals 2 minus 3. So all we have to do is just work out this math for both of them, and we'll be pretty much done with that answer. So for the first one, 2 plus 3, 5. For the second one, 2 minus 3, that's going to be negative 1. So I'll write both of my answers here, x equals 5 and x equals negative 1. I'll just separate the 2 by a comma because I'm lazy. That's pretty much it. Sorry, I just realized that wasn't showing. But that's pretty much it. Now I'm going to move on to several examples. If you have this worksheet in front of you, I'm going to be doing examples 1 through 9 and only the odd numbered ones. So starting with number 1. Here we go. X squared equals 49. Now this looks a lot like the very first example that we had. So I'm going to use the same method. All I have to do is take the square root of both sides. These two cancel. And I have x equals the square root of 49. Which, if you take a minute to pause, you can figure it out. But that would be plus or minus 7. Okay, number 1, off to a pretty good start. Let's move on to number 3. And I'm going to switch papers so that the pen does not bleed through. All right, so example 3 is x squared plus 36 equals 0. So this problem here looks a lot like the second example that we had. So all I have to do is subtract 36 on both sides in order to get x squared by itself on one side. And when I do that, I'll end up with x squared equals negative 36. So take the square root of both sides and we'll be all set. Except, think back to when I said if we have a positive times a positive, we'll end up with a positive. And if we have a negative times a negative, we'll end up with a positive as well. But somehow we have the square root of a negative number, which means we have to find what number multiplies to a negative number when you multiply it by itself. And that means the signs have to be the same as well. So unfortunately, because we have a negative square root and a positive times a positive is a positive, as well as a negative times a negative is a positive, there's no way without diving into imaginary numbers that this will get an answer for us. So what we have to say is that there are no real solutions. Anytime you take the square root of a negative number, you will never have a real solution. So we could be done after that. Now moving on to number 5. We have x minus 2 squared plus 3 equals 10. So again, with the x minus 2 inside the parentheses, nothing changes at all. It just looks a little bit more complicated than it actually is. But this time we have a plus 3 on the outside of those parentheses. So we're going to have to get rid of that first by subtracting 3 on both sides. Now we'll have x minus 2 squared equals 10 minus 3, which is 7. All right, so now that I have the squared number on one side and everything else on the other side, I can finally take the square root of both sides. So I'll end up with x minus 2 equals the square root of 7. After adding 2 to both sides, you'll also notice that there's not really a nice answer for the square root of 7. So when we get to this point, I want you to leave the number inside the square root, because if we know that whatever answer we get is going to be either positive or negative, then we can just stop there and make sure we indicate that this answer will be positive or negative, and we'll have to take into account both of these possibilities. So you can leave your answer like this, or you can separate it, x equals 2 plus the square root of 7 and x equals 2 minus the square root of 7. Totally up to you. This way looks a little bit cleaner in my opinion, and also I'm lazy, so I don't like to write more than I have to. Okay, so moving on to 7, we're at the penultimate question here. X squared minus 81 equals 0. So I'll add 81 to both sides. Cancel those. X squared equals 81. Now if you know the square root of 81, then we're good. Cancel the square and the square root on this side. The square root of 81 is going to be plus or minus 9. So that's it for that answer. Moving on to the very last odd number problem here, we have x plus 7 squared equals 1. So again, we have one term that's being squared since it's in those parentheses right there. So I can just go ahead and start off by taking the square root of both sides. That will cancel with that, and we'll have x plus 7 equals the square root of 1. Okay, this time I'll take the square root first. So I'll rewrite this side, x plus 7. The square root of 1 is just going to be 1 because 1 times 1 is 1. But it will still be a plus or minus 1. Keep that in mind. Lastly, I will subtract 7 on both sides before I can separate my answer. So I'll have negative 7 plus or minus 1. The reason why I flipped these two numbers around is because I like to have the plus or minus second. That's just my personal preference. You can do whatever you want. Okay, separating the two, x equals negative 7 plus 1, x equals negative 7 minus 1. And so when I do that math in my head, I know the first answer is going to be negative 6, and the second answer will be negative 8. Cool. So that's pretty much it. That's all I got for everyone here. Don't forget to smash that like button, leave a comment, subscribe so that you're notified of future recordings, and stay Gucci, everyone.